All right, guys, we're back and we're going to talk more about exactly what we're looking for when we do a forensic analysis. So first off, the most important thing to look for that most people probably wouldn't realize to look for is deleted evidence. Just because something's deleted doesn't mean it's gone. Okay? So I'm sure you guys have downloaded and installed big programs, right? I downloaded a new video game and it's 20 gigabytes. That's a big download. Takes a while to download, takes a while to write all those ones and zeros to my hard drive. It installs the thing, it takes half a friggin' hour. But finally it's installed, I'm ready to play. I go, I play it, I love, I got tired of the game. I've played it too much or I didn't like the game, whatever. I go to delete it. How long does it take to delete it? Is it the same half an hour that it took to install it? No, it takes like seconds to delete something. Because when a computer deletes something, it's not really gone. All your file system does is say, hey, the allocated space that we have for those files, that's now unallocated space. That's all it does, is it marks that space from allocated, i.e. it contains a file, to unallocated, meaning the file system thinks it doesn't contain a file. But it still does. If you look at that physical hard drive, the ones and zeros that compromise all those files are still there. It's just that your file system thinks that that unallocated space is empty. It's not really empty, okay? So if we know that, we can go into all that unallocated space and say, look, what's still here? The file system thinks it's empty. The file system is saying that we can store stuff there because there's nothing currently there, but there really is something currently there. All the ones and zeros that compromised all that deleted evidence can still be read, right? So that file carving, that finding these deleted data is done automatically with most modern forensics tools. So like FTK and NCase, when you put in an image and process the image, and FTK goes through and looks at that, all the different sectors and looks at all that stuff, and the case is ready for you, it will say, hey, I found all these deleted files. And there's actually a tab right there that just says deleted files. And you can look through all the stuff that it found that was deleted prior to you arriving and taking your image. So that is a very, very good source for evidence, especially if the bad guy doesn't realize that deleting something doesn't mean it's actually gone. Okay? Now, there are three ways to actually permanently delete data. The first is wiping, right? The thing we talked about in the previous subsection, where you go over either the entire hard drive or just a small part of the hard drive, and you write ones and zeros, ones and zeros, ones and zeros. That overwriting process will permanently delete something. Most of the time, even overwriting it once will permanently delete it. But the second way to permanently delete something is to physically destroy the hard drive. If you take your physical hard drive out of your computer and you toss it in an incinerator and it burns up, or you send it through a wood chipper, or you smash it with a hammer a whole bunch of times so that the platter's all broken into pieces, or you throw it in the bottom of a lake, or whatever. Physical destruction of the hard drive to the point where like the platter is in pieces and really, really destroyed, you can't get the evidence back. The third way is with a magnet, which again, kind of, you can't be selective about. It would just be the entire hard drive. But if you take a really big, powerful magnet, that will wipe out the data on a drive. Because again, modern platter hard drives, that the entire way it writes ones and zeros to that drive is with magnetics. So if you have a big magnet, it will mess up that process and will scramble all the ones and zeros. The physical destruction of the magnet, basically you need to do the entire hard drive, right? There's no way you can just physically destroy or magnetize a small part of the drive. With wiping, you can do that strategically. You can just wipe one tiny part of the hard drive where you knew something was, but you don't have to, buy a new hard drive and start all over like you do with the other two methods. But just erasing and overwriting something is usually enough. So with our previous example, I've downloaded the computer game, I played it, I didn't like it anymore, so I deleted it. At that point, it's still, I can find the old files that compromise that game. Even though they're in unallocated space, the file system thinks that unallocated space is free, I can still find those files. But now let's say I download a second game, a new game. My computer is going to choose essentially a random place within unallocated space to save those files. If it by chance happens to choose the same place on the hard drive that my old deleted game was stored, it will overwrite those old files. And that usually means the old files are now gone. It could overwrite all of the file, could overwrite only part of the file. If it's part of the file, we can still find the part that was not overwritten. If it's overwritten the whole file, usually we can't find any of the original file. But there is occasionally, very occasionally, a thing called shadow data, where they erased the old data and overwrote the old data, but they left just enough of the original data behind to be able to go in and find it. But that is an incredibly difficult thing to do. It's a very, very difficult process, and it's very rare that somebody would spend the time and energy and money to go in and find that shadow data, but it is possible, which is why the Department of the Defense, when it wants to permanently delete data, their wiping process doesn't just do it once. It does it 8 times or 10 times or whatever the new standard is. And because it's done multiple times, the odds of that shadow data still existing are basically 0. Okay? But even if shadow data does exist, it's incredibly difficult to find, to the point where overwriting something once the vast majority of the time means it's gone. Okay? So, we're also looking for hidden evidence, things that the person has specifically tried to hide. Now, the easiest, most common way to hide data is with encryption. That can be very good, because encryption can be very hard to break, mathematically. But encrypted data also sends up a really big red flag. So if I load an image into FTK and say, hey, process this image and tell me what I got, one of the first things it's going to do is look and say, hey, look, there's an encrypted file right here. There's an encrypted file. That might be a bad thing, right? Because encryption isn't perfect. There are lots of ways to get past encryption. And encrypting your data sends up that big red flag. Encrypted data is really obviously encrypted data. So we might want to hide it in other ways without using encryption. One of the ways to do that is what's called hiding in plain sight. So essentially you can change the file extension of a file to make it look innocuous, right? So if you have a Windows machine, you can open up Windows Explorer, look through your Windows directory, and there will be 1,000 different files in there that nobody really has any idea what the heck they do unless you work for Microsoft or you're, some tech support person. But everybody knows you don't mess with, right? It's like system32.dll. Most people, most computer users have no idea what system32.dll actually does. They just know it's important and not to mess with it. So what you can do is, say I download a bunch of child porn images. I can rename one of those images system33.dll and put them in that same file as system32.dll. Anybody who's looking through that, any kind of, just amateur person looking through it, is going to be like, oh, there's no images there. It's just these random DLLs that Windows needs, and I know not to mess with them, but I don't know exactly what they do, but I don't really care, because in this case, it's not important. But me, if I ever want to view that child pornography again, I just have to change it from system33.dll back to the original file name, open it with whatever picture viewer I choose to use. Then when I'm done, close it, rename it back to system33.dll, and that is hidden. But remember what I said in the last subsection. Each different file extension has a different header and footer. And telling Windows that your .jpg is now a .dll doesn't change the header and footer. It just changes what Windows thinks the file extension is. As such, we load those into FTK, and that's also going to bring a big red flag. Okay, FTK is going to say, look, this is claiming to be a .dll file, but the header and footer mark it as a .jpg file. You might want to check that out. It puts up a big, like, hey, look at these kind of thing. Another way to hide evidence is steganographic data, which I talk a lot more about in one of the technical videos that have also been posted on this channel. But steganographic data essentially means hiding data within other data. And this can be much more difficult to find, much more difficult to even know it's there. So if you have this steganographic data, that can be a very, for the forensics person, not only is it hard for them to know it's there, it's also hard for them, if they do figure out, oh, there's some steganographic data here, it can also be very hard for them to figure out what that steganographic data is. Okay? So if you want to know more about that, watch the technical video where I talk a lot about steganography and how it works and why it's done and all those things. Okay? Last thing we're going to talk about is forgotten evidence. These are things where most computer users don't even realize that computers are saving this stuff. And so when they try to delete all the evidence of their misdeeds, they didn't know it was being created in the first place, so they don't know to go and delete it. So the first thing to talk about are temp files, or temporary files. Lots of different programs use these to help the user. They're there as a convenience for you, the computer user. One of the common ones that do this is like the Microsoft Office suite. They all have these temp files. So it used to be, if I was writing a paper, and I'm like 2 pages in and I'm going and it's great and I'm typing, and then the power goes out. Oh man, that stinks because I hadn't saved my file yet. Thus, the only place that file existed was in RAM. And when the power went out, all my RAM got wiped because RAM is volatile data and only exists when power is on. So when the power went out, RAM is gone. I didn't save my file to the hard drive, so now it's gone. I have no recourse. All that stuff I wrote, all the 2 pages of the stuff I wrote is gone. Because of that problem, Microsoft created this system where every 30 seconds or every minute or something like that, Microsoft Word will automatically save the work you're doing in this temp file. Now, I'm 2 pages in, the power goes out, oh, my paper's gone because, the RAM is gone. I reboot my computer, I bring it back up when my power's back on, I open up Microsoft Word, and because it saved this temp file to the hard drive every 30 seconds or minute or whatever, when I open up Microsoft Word, it says, hey, you were working on this file, and then, Word shut down unexpectedly. Do you want to bring it back up? And I'm like, yes, oh, thank you, Microsoft Word. Oh, you're the best. I didn't lose all that work. I bring that up, and I keep going. Normally, those temp files are deleted after you're done writing the paper. So once I hit File, Save, and close Word, Word will automatically delete that temp file. But remember what I just said 2 slides ago. Just because something's deleted doesn't mean it's gone. So let's say I'm a terrorist. I write out my terrorist demand letter or whatever, save it in Microsoft Word, print it off, mail off the printed copy, go onto my hard drive, and I say, okay, I want to make sure that I want to wipe the area of my hard drive where I saved that text file. So I overwrite that little section of the hard drive. That evidence is now gone. But he forgot to overwrite where the temp file was saved. As such, we can go in, find that temp file that Microsoft Word conveniently created for us, and find all the evidence we need right there in that temp file. In a similar way, web browsers create what are called cache files. C-A-C-H-E, cache. The first time I go to a website, say NFL.com, I have to download every piece of that site from the server that hosts it to my computer. All the images, all the fonts, all the everything. But those get saved in what's called a cache file. Now, the second time I go to that website, essentially the website says, hey, do you have any of this stuff already? And my computer says, oh yeah, I've already got most of these files. You've changed a little bit since the last time I was there, but I've still got most of it. And I can just load that from my hard drive rather than having to re-download everything from your website to my computer. It saves time, it saves bandwidth, it saves energy, makes web browsing a lot easier, but it also saves a record of all those different websites you've been going to onto your hard drive. Again, it's designed for your convenience to make things easier for the user, but in reality, it's a great place to find evidence, because what website somebody's going to can absolutely be a very important piece of any criminal investigation, right? The third one is what's called a swap file, okay? And this is kind of temporary extra RAM. So let's say I have 8 gigabytes of RAM in my computer, but I have a whole bunch of stuff going on my computer, and my computer needs 9 gigabytes worth of RAM to do it all. As a convenience for the user, modern computers will say, look, I only have 8 gigabytes of real actual RAM. I need 9. So I'm going to take 1 gigabyte worth of hard drive space and treat that like RAM. And I'm going to choose the 1 gigabyte worth of that 9 gigabytes worth of stuff my user wants in RAM. I'm going to choose the 1 gigabyte that really, where speed doesn't matter, right? Because remember, the entire reason we have RAM and don't just work directly from a hard drive to the processor is for speed. RAM works way faster than a hard drive does. Thus, we still have that middleman between the hard drive and the processor to speed up our computer. But if speed really isn't an issue, we don't really need speed for this particular memory, we can take that 1 gigabyte out of the 9 gigabytes of total stuff we need in RAM and put it on the hard drive and work directly from hard drive to processor just for that little bit. Okay? It's called a swap file. That swap file gets saved on the hard drive, and again, that is a great place to find evidence. So even though he didn't technically save something to the hard drive, it might have been in the piece of his RAM or in that chunk of RAM that got saved as a swap file onto the hard drive. And thus, we might still be able to find it even though he never actually purposefully saved it to the hard drive. Does that make sense? All right. So, at the end of this whole process, we need to report our findings. What we need to be really careful about, though, is what's called confirmation bias. So essentially, confirmation bias means we're only going to see what we want to see. So if somebody brings us a hard drive and says, look, this hard drive is from a bad guy, or this cell phone is from the guy who committed the murder, our natural human reaction is to assume that this guy committed the murder. That's what the police officer who brought us the cell phone to analyze said. That's what we're going to be looking for. But we need to make sure we're looking in a neutral way. We need to make sure we're looking not only for evidence that the person is guilty, but evidence that the person might be innocent too. I mean, that's the ultimate cause of justice, right? If they're guilty, we want to find the evidence that they're guilty. But if they're not guilty, we need to find the evidence that they're not guilty so we can actually send law enforcement after the person who did do it. So make sure you're not only finding the stuff that tends to make the person look guilty. Be neutral, find all the evidence, whether it makes the defendant look guilty or not guilty, and make sure you put all of those in your report. The good thing about FTK and NCASE and most forensic tools is that they have a built-in reporting function. So this is the FTK reporting function here. All you have to do, once you do your investigation, and you can, say there's a child porn file, you can click that file and say, bookmark this file. And then it will go on the report. And you can say, you input stuff about that file. I found this file in such and such folder. This is why this file is important. Then, you find their Skype chat logs. You bookmark that file and put in, yeah, this Skype chat log shows that he's talking with such and such person on such and such a date. Then you find their, a video of the person grooming a child, and you bookmark that video and say, this video shows the defendant doing the... Then once you're done doing all that bookmarking and all that labeling and all that stuff, you go to File Report, and it pops up with this handy tool. And all your bookmarks are there. All the graphics you've tagged are ready to go. All the videos, everything is in there, ready to go. Plus it has, your law enforcement agency or lab name, has your name, it has your address and phone number, it's got the case number, it's got the evidence number of the hard drive you did the analysis on, all that in one nice package. And then it gives you the report in both a digital format and a printable format. So if the prosecutor or the law enforcement person or whoever you're sending that report to, if they want it digitally, boom, email it right off to them. If they want a hard copy, boom, print it out, hand it to them, big stack of papers, there you go. You also have to be careful though, because at some point you're going to have to go testify in front of a jury. And as I said in a previous section, testifying in front of a jury about seriously technical topics like this can be very, very difficult. It's hard to make 12 people who have no idea how a computer works understand why the hash matching between the original device and your image means that nothing was changed. It's hard to make them understand that deleted evidence really isn't gone. It's hard to make them understand what you're testifying about. So you need to practice. You need to understand how to convey your report, how to describe your report, how to tell the jury what you did in such a way that they're going to understand. They don't have to understand all the super technical details. They have to just understand enough to put the evidence and the testimony you're providing into the proper context. And that is a very difficult job to do. But I hope one day you'll be able to do it, because it is a very satisfying thing to be able to go to a jury and say, look, I found this evidence. There's no way it was faked. This, digital evidence really makes a jury happy if they understand what it really means. Okay? That's the end of whatever section we're on. See you next time.